In this example, we're going to be looking at, or in this video, we're going to be looking at example 7, which is on page 598 in your book. And I felt it was important to go through this one because it uses a technique with logarithms, and this is something that might show up on an IB test. So I just want to remind you before we get into this problem of the rule of logarithms that's going to be coming up. Remember that if we have the log, and it can be log base any base, log of any base, of say b to the c power, that the rule says that you can bring this c out in front. So I can bring it out in front here. So I can do c times log base a of b. And like I said, this rule applies no matter what base logarithm you use. And since you have a calculator to use, we're probably going to use either log base 10 or log base e. And remember that log base 10 just shows up on your calculator as log, L-O-G, and log base e shows up on your calculator as ln. And it doesn't matter which one you use. You can use either one. Your book uses log. It uses this one. When I do the example, I'll probably use ln. Okay, so it says a box contains a large number of carnations. And now notice that they're not telling us how many carnations are in this box. It's just a really large number. A quarter of them are red and the rest are white. So here's my box. 1/4 of them are red. 3/4 of them are white. Then it says we're going to pick carnations out of the box. So we're just going to keep picking carnations out of the box. And it says how many carnations must be picked so that the probability that there's at least one red carnation among them is greater than 0.95. So again, notice we don't know what the value of n is in this one. Well, we don't know how many are in the box. We also don't know how many we're going to pick. They're asking us to find the number that we're going to pick. So we can see that this is a binomial distribution if we let x equal the number of red carnations, because that's what we're going to be counting. And we can say that x follows a binomial distribution with n trials, because we don't know what n is. They're asking us how many do we have to pick. And the probability of success, the probability of getting a red, is 1/4. And then I also want to point out the sample space for this one. So we're going to pick out some specified number of carnations, and so out of that number we might get 0 red ones, we might get 1 red one, 2 red ones, and so forth. Now what they're asking us to find is the probability that there's at least one red carnation among these that we pick. So we want the probability of that x is greater than or equal to 1 is what we're looking for. And we want that to be greater than 0.95. All right, so now what we want to do is also think about the formula for this. So remember, and we reviewed this on the first page, that the formula for probability for binomial is probability that x equals x is n choose x times p to the x times 1 minus p to the n minus x. So the other thing to remember is that if we're looking for the probability that x is greater than or equal to 1, we're looking for these numbers right here, and that's going to be the same as 1 minus the probability that x is equal to 0. And in the homework problems that you're going to do, every single one of them asks you basically for the same thing, for the probability that you get at least 1, the probability that x is greater than or equal to 1. And so every single one of them is going to turn into a problem that looks like this. So what we're going to do now is fill in what the probability that x equals 0 is from this. And our particular problem is the probability that x is equal to x is going to be n, which we don't know, choose x. And then the probability of success is 1/4, so 0.25 to the x. And then 1 minus 0.25, which is 0.75 to the n minus x. So if we want the probability that x is equal to 0, specifically, that's going to be n choose 0 times 0.25 to the 0 times 0.75 to the n minus 0, or just n. So notice that this is just going to turn into, this is 1, this is 1. This is just going to turn into 0.75 to the n. So now if we put that back in here, All right, we've got probability x is equal to 0 is this. So I'm going to put that in here. I get 1 minus 0.75 to the n. We want that to be greater than 0.95. Excuse me. So we need to solve that inequality. So the first thing we'll do is subtract 1 from both sides. So I end up with negative 0.75 to the n is greater than negative 0.05. And then I'd like to get rid of those negatives, so I'm going to multiply both sides by a negative 1. And I just want to remind you that when you multiply an inequality by a negative number, that you have to switch the inequality sign. So this is going to become 0.75 to the n is less than 0.05. So now we want to solve that equation, and this is where the logarithms come in, because we're solving for this exponent, or we're solving for the variable which is up here in the exponent. And so we want to get it out of the exponent. So what we're going to do is take the logarithm of both sides, and like I said, you can use log any base. I'm going to use ln, just to be different from your book. You can look at the book to see what they do. And we're taking the log of this 0.75 to the n. And then on the other side, we're taking the log of 0.05. And so on the left-hand side, if we use that rule that says we can bring this in front, then this is going to turn into n times the natural log of 0.75 is less than the natural log of 0.05. And then we're going to divide both sides by the natural log of 0.75. Now remember again, whenever you multiply or divide an inequality by anything, you have to be careful about whether you're multiplying or dividing by a negative. And it turns out that this is a negative number, right? You can put that into your calculator. Just type in ln of 0.75. You'll see it's negative. So that means we're going to have to switch the inequality sign. These divide out. So it becomes greater than. And then this number, when you put this into your calculator, turns out to be 10.413 and so forth. Now remember that n has to be an integer. It has to be a positive integer, because it's how many trials we're going to have of this experiment. So if n has to be an integer and it has to be greater than 10.4, then n would have to be 11. Now it turns out that you can also solve this inequality right here using a graph, or you can also use a table. And I will, in a separate video, show you how you can solve that with a graph or a table.